Hey folks, this video is going to be really short, but I wanted to make sure that we understood what a diffraction grating was, and we'll see one on a really short virtual lab that we'll do tomorrow. So let's jump right into this because I don't want to waste your all's time. All right, so we have a diffraction grating. We are going to have a 550 nanometer green light that's incident upon it. And the grating has 150 lines per millimeter. Okay, we'll have a screen that's placed 2 meters away from the grating, and we want to know how far from the central maxima is the second order maxima. Okay, so what we've been focusing on so far is single and double slit apparatus, and now we're going to move into a diffraction grating. The good news for us is the diffraction grating is pretty much the same thing as a double slit apparatus. The only thing different is that instead of having 2 slits, there's lots and lots of slits. So what it does is it ends up, you have the interference patterns that result in several point sources now. But what happens is it just ends up splitting it up a little bit. So remember, when we bring the slits closer together, it spreads the diffraction pattern out. So this diffraction grating has 150 lines per millimeter. Okay, so in a nutshell, what this is, imagine just taking a piece of glass, okay, and then taking a sharp blade and then etching a vertical line. Now you got to put 150 of those every millimeter. Okay, so obviously the first ones that were made were very, very crude because it was just done by hand. But now they use lasers to end up etching the glass plates so that we get the different lines in them. So there's 150 vertical lines every millimeter in order to solve for this. So the good news is everything stays the same. So we have our diffraction grating, we have our green light incident. Here's your central maxima, here's M1 maxima, and then here's M2. So to solve, the first thing that we want to do, we're solving for this distance right here. Okay, so the first thing we need to do is get this angle. All right, since we have 2 different ways to get the angle, we use our double slit equation, so d sine of theta equals m times wavelength. But distance on this one is the distance between the slits. Okay, so what we have to do here, since this is 150 lines per millimeter, that means there's 150,000 lines per meter. So what we want to do is inverse this number and have meters per line so that we end up putting 1 over 150,000 for this. That is really the only difference in the diffraction grating, is we need the distance between the individual slits. Okay, so you just have to change this to the proper unit in meters and then inverse it when plugging into this equation. Okay, so 1 over 150,000 equals times sine of theta equals, and remember, since we're going to M2, we put a 2 here, times the wavelength, which is 550 nanometers. Okay, so what we get is an angle of 9.5 degrees. And then, since I know the distance to the screen, I can switch over to tangent. So tangent of 9.49 equals x over 2. And we get x2 is at 3.334 meters or 33.4 centimeters. Okay, that's it. That's the only other thing with these, with this topic. I really have everything in with this. All we have left is thin film interference, and this unit is over. So expect quiz probably next Wednesday, I would expect. Okay, all right, see you guys later.